Hello everyone, welcome to Learn Spring Boot with Bingyang. In this video, let's embrace OpenAI's ChatGPT and harness its advanced AI power to implement one feature for our Spring Boot application, Hogwarts Artifacts Online. So here we go. Recall the project, Hogwarts Artifacts Online, that we have used throughout this entire tutorial. Our client, the headmaster of Hogwarts School of Witchcraft and Wizardry, is pleased with the application that we developed for organizing their magical artifacts and wizards. The wizards at Hogwarts recently learned OpenAI's ChatGPT. It was said to possess an almost magical power, one that didn't require wands and magical spells, but something called algorithms. The wizards want to investigate if the muggles, non-magical humans, at OpenAI are secretly working on a new form of magic. So, they came to us with a new requirement for the Hogwarts Artifacts Online project. The application shall use OpenAI API to generate a short summary of the current catalog of magical artifacts. They want to evaluate how powerful this mysterious and enchanted AI algorithm is. So let's go for it. First, let's add this requirement to our user story document. This mind map stores all the user stories that we created. As you can see, I have already added this new user story under the Artifact Management module. As an anonymous user, I want to get a summary of the existing artifacts so that we can quickly understand the key details of numerous artifacts. By the way, the link to this mind map is available in the description of this video. Next, I will follow the API-first approach and clearly define a new API endpoint for this user story. Let's go to SwaggerHub. This is the API document for our Hogwarts Artifacts Online project. As you can see, I have already added a new endpoint /artifacts/summary to our Swagger API document and upgraded the document version to 2.1.0. The link to this API document is also available in the description of this video. So let me expand it. This new get API endpoint generates a summary of the existing artifacts and returns it to the user. No parameters are needed. Here are some possible responses. For the happy path, code 200, recall that there are 6 magical artifacts in the database. As you can see, this is a pretty good summary. It talks about each artifact and its owner. We need OpenAI to generate this for us. Other responses are about errors. For example, we may get a 401 unauthorized error, either incorrect API key provided, like this one, or API key not provided, like this one. It is also possible that we have used up our OpenAI API quota. That is a 429 error. It reminds us to pay the bill. There are also 500 and 503. Right now, there are over 100 million weekly activity users of OpenAI. So don't be surprised. There will be some server-side errors. Okay. Having designed an API endpoint, next, let's do a quick object-oriented design for this API endpoint using the UML sequence diagram. Let's go to the slides. This is the sequence diagram that describes the object interactions for the new API endpoint. We read a sequence diagram from left to right, from top to bottom, following the arrows. Arrows with solid lines represent method invocations, Arrows with dotted lines represent returned values. I also color-coded each object in this sequence diagram. Green means Spring Framework's objects. Red means objects we defined or need to define. It all starts when the user or the front end sends a request to our API. They're looking to get a summary of the existing artifacts. So they hit the endpoint /artifacts/summary. Upon receiving this request, the baton is passed to the artifact controller. Think of this object as a gatekeeper. It's responsible for managing incoming requests, like the one we just received. Now, Artifact Controller does not do all the heavy lifting by itself. It delegates the task to ArtifactService, which prepares the data required for generating the artifact summary. This step is crucial for accurate and efficient processing. Once ArtifactService has everything set, it's time to call in the OpenAI ChatClient. To accomplish its mission, OpenAI ChatClient uses a tool from the Spring Framework called RestClient. This tool reaches out to the remote OpenAI API, which is where the real summarization takes place. So this is where the magic happens. Once the summary is ready, it's sent back along the path it came. The response is returned to the RestClient, and then it goes back to the OpenAI ChatClient, which then relays it back to ArtifactService. Our ArtifactService receives the summary and passes it back to Artifact Controller. Finally, Artifact Controller packages this generated summary into a neat response format and sends it back to the front end, completing our sequence. And there you have it. This is how our system handles a request for artifact summarization from start to finish. It's pretty straightforward. I'm sure you're already familiar with the Artifact Controller and ArtifactService. But here, I want to clarify the term client in the OpenAI ChatClient class. This is a naming convention when a Spring Boot application is invoking an external service. So, external service name, client. The term client here indicates that this object is responsible for interacting with external services or APIs. It suggests a more specific role focused on the communication aspect, like making API calls, handling responses, and dealing with connection details. Remember, this OpenAI ChatClient does not provide the AI service itself. That's why I'm not naming it OpenAI Chat Service. There are two objectives in this video. The first one is learn and get familiar with OpenAI API, so you can incorporate it in your future project. The second objective here is to learn to make API calls from Spring Boot to remote REST services using RestClient. RestClient is a Spring Framework built-in synchronous HTTP client. In our case, we'll send API requests to OpenAI API and retrieve the responses. Let's start with the first goal, OpenAI API. There are two ways that we can interact with OpenAI's AI model. The easier way is through its web user interface, ChatGPT. So let's use ChatGPT web user interface first to do some proof of concept and see its capabilities. Our goal is to summarize the artifact data. So first, let's get them in JSON format. So let's access this endpoint. As you can see, this API endpoint returns us an array of artifacts. So let me copy this JSON array. And then go to ChatGPT. Next, I need to come up with a prompt for ChatGPT. Your task is to generate a short summary of a given JSON array in at most 100 words. The summary must include the number of artifacts, each artifact's description, and the ownership information. Here is the JSON array, colon. Then I'm going to paste the JSON array that I just copied. So paste. All right. Then just enter. As you can see, ChatGPT is thinking. So let's scroll down. Wow, that's magic, right? So this is a pretty good response. But as you can see here, in the summary, it mentioned the given JSON array. I do not want that in the summary. So let's add an extra instruction in the prompt. So that means I have to copy the previous prompt. And here I'm going to modify it. Don't mention that the summary is from a given JSON array. Okay, everything else is the same. So press enter. Okay, now as you can see, ChatGPT follows my instruction. It just says the collection comprises 6 unique artifacts. It is no longer mentioning it is from a JSON array. So it's pretty amazing. Okay. So I mentioned prompts. So what are prompts? Prompts are the initial inputs or instructions provided by users, which guide the AI model's responses. A prompt can be instructions, like the one presented here, questions, examples, statements, or a combination of these. Basically, a prompt sets the context and direction for the AI model's response. As you can see, the way you phrase a prompt has a significant influence on the AI model's output. So in a nutshell, the prompt helps the AI model understand the structure and intent of the user's query, leading to more precise and relevant responses. The ChatGPT web user interface is quite impressive and practical for a range of one-time tasks. However, it is not feasible to expect our users, the users of Hogwarts Artifacts Online, to directly interact with this web interface for their needs. To address this, we'll explore how our Spring Boot application can directly communicate with ChatGPT. This approach will enable us to seamlessly integrate AI capabilities into our application, providing users with the benefits of ChatGPT's amazing functionality without the need for manual intervention on the web interface. So the second way to interact with OpenAI's AI models is through REST APIs. Next, let's replicate what we just did in the ChatGPT web user interface using OpenAI API. Here is the documentation of the OpenAI API. Since we will use this API, it is a good idea to understand what the API expects from us. The request format. Let's go to the quick start. And change this to curl. All right, so right here. Let's take a look at this curl command and its options to understand the API request. This is the API endpoint that we will use. It has 3 parts. The first part is the base URL, which is https://api.openai.com. The second part is versioning. Right now, it is v1. If you watch this video in the future, change the version to the latest one. The third part is called endpoint path. Each functionality offered by the OpenAI API is accessible through specific endpoint path. For example, in this case, it is /chat/completions. So what is chat completions? It's very simple. Users provide a text prompt, And the AI model returns a continuation of the prompt to complete the chat, just like the one I showed you in the ChatGPT web user interface. So text in, text out. And in this video, we're going to use this endpoint path. There are other common endpoints. You can find them here in the API reference, like here. So here you can see the common endpoints include audio, chat, that's the one we're going to use, embeddings, fine-tuning, files, images, models, and moderations. As you can see, the OpenAI API can handle multiple types of input and output. It's pretty powerful. Okay, so let's go back to the documentation. Let's move on. The request has two headers, content type, which is application/JSON, and authorization, which stores the authentication token, in this case, the OpenAI API key. So to use OpenAI, you need to generate an API key first. I have already registered with OpenAI and got my API key. So it's right here. But this is not enough. You will also need to add credit into your account. So let's go to Settings and click Billing. Now, as you can see, right now I have $9.20 in my account. If you use up all your credits, you will get a 429 error. Okay, so let's go back to the curl command. So here, -d means data that we're going to send in a post request. So let's take a look at the request body. Here, the first parameter of this request is model, and the value indicates the model to use. Here, it is using GPT 3.5 Turbo. Then what is an AI model? An AI model is a kind of mathematical function. In essence, it maps input data to desired output based on the patterns learned from a large amount of training data. For example, an image recognition AI model takes input like an image and outputs labels or categories, like identifying objects, faces, or scenes in the image. In this case, the AI model is a large language model. It takes input like an article and outputs a summary of this article. In this video, we will use GPT-4 model for summarization task. The second parameter in this request is called messages, which includes an array of messages. Each message has two things, role and content. In the first message, the role is system. This is used to provide high-level instructions. So for example, here we use this system message to set the AI model's behavior. The content is, you are a poetic assistant skilled in explaining complex programming concepts with creative flair. Okay, so this one sets the context and the background for the AI model. And then the second message, the role here is a user. This user message basically is a query or request from the user, like you and me. So based on this context we set in the system message, in the user message, the user is requesting, compose a poem that explains the content of recursion in programming. So it's pretty interesting. Okay, now we have a good understanding of this curl command. Let's do this in Postman. So first, let me copy this endpoint. And let's go to Postman. Let's create a new HTTP request. And remember, that's a post request. And here I'm going to paste the endpoint. We also need to set up the authorization. Let's go here and let's pick the bearer token. And here I'm going to paste the OpenAI API key. Then let's go to the request body. And let's choose raw. And this should be JSON. Here we need to define the model, and the messages. So let's go back to the curl command. And let me copy and paste this. Paste. And as I said, we're going to use GPT-4. And then we have to change the content. So first, copy and paste, and so on. And here, we need to provide that JSON array. Since this JSON array contains double quotes, which are reserved in JSON, so they must be properly escaped first. I used an online tool to escape the double quotes, and I've already copied that. So let me paste it here in the content of the second message. So paste. Now, as you can see, we used backward slash to escape the quotes in the JSON array. All right, are you ready? So everything's fine. Let's go ahead and send. As you can see, it takes a while. Very good. The OpenAI API returns us a response, which is also in JSON format. As you can see, this JSON object contains several fields that detail the result of our API call to OpenAI's chat completion endpoint. Let's go over them one by one. It's important to understand this since we need to handle the response in Spring Boot. ID is a unique identifier for this chat completion. It can be used for reference or tracking purposes. Object specifies the type of object returned, which in this case is a chat completion. Created indicates when the response was generated. Model indicates the AI model used by OpenAI to generate the response. Here, it is a variant of the GPT-4 model. But we're more interested in the next section. Choices is an array of responses provided by the AI model. In most cases, this will only contain one element unless specified otherwise in the request. So in this case, there's only one choice. Each choice has an index. Index indicates the position of a choice in this array. It starts from 0. Since there's only one choice, so index is 0. Message contains the actual response from the AI. As you can see, this is an assistant message. Assistant here indicates that this message is a response from the AI model. So this is different from the message that we sent in the request, like here. So this is a user message, and here is an assistant message. Content is the text of the AI model's response. In this case, it's the summary that we need. Log props means log probability. It does not apply here. Finish reason indicates why the AI model stopped generating further text. Here is stop. It means it reached a natural conclusion in its response. Next is the usage information. This section provides details about the token usage in this request. Why? Because money. OpenAI charges you based on how many tokens it processes in your request. So the prompt tokens is the number of tokens used in the prompt. Completion tokens is the number of tokens the AI generated in its response. And total tokens is just a summation of the previous two. In this case, system fingerprint is null, but this field could contain system-related information if applicable. Okay. Understanding the structure of a request and a response is crucial for effectively using the OpenAI API. Next, let's go back to the slides and do some object-oriented design. Now that you have a good understanding of the OpenAI API request and response JSON format, we need to properly represent those important concepts in Spring Boot. Here, I came up with 4 classes based on the request and the response you just saw in Postman. I call them DTOs, or Data Transfer Objects. Let's look at chat request and message first. We can use these 2 classes to represent a request to the OpenAI API. On the right side of the slide, you can see an example request in JSON format. A chat request class has a field called model, which corresponds to the first element in the JSON object. This class may also contain one or more messages. A message class has a role field and a content field, which corresponds to the role and content in this JSON object. So this is how we represent a request in Spring Boot. For the response from the OpenAI API, we need 3 classes to represent it. On the right side of the slide, you can see an example response in JSON format. As you can see, a chat response class contains one or more choices. A choice class has an index field and is associated with a message. And again, each message has a role and a content. This design corresponds to the response JSON object on the right side of the slide. In this design, I ignored many fields in a response, like ID, object, created, model, and so on. So feel free to add those fields in the chat response class if you need them. All right, we'll first define those classes in our Spring Boot application. Let's come back to the sequence diagram. After defining those DTOs, we will first implement the OpenAI ChatClient, then ArtifactService, finally ArtifactController. All right, our roadmap is clear. Let's go to IntelliJ and do some coding. Let's create a new Git branch first. Artifact summarization. Okay. Let's create a new package to hold the classes we will create in this video. Let's call it client, and under client, let's create a package called AI, and then under AI, let's create one more package called chat. I want to remind you that the term client indicates the responsibility for interacting with external systems or APIs. In other words, only the communication aspect, like making API calls, handling responses, and dealing with connection details. In the future, there will be more external services that our Hogwarts Artifacts Online use. For example, notification client and cache client. And we will create more packages, for example, client.notification and client.cache. But right now, there's only one package under client. It's AI. Also, the same idea for chat. In this video, we're only using one magic power from AI, the chat completion. In the future, maybe we want to use AI to generate an image or to interpret an audio. So we will have AI.image and AI.audio. But right now, there's only one package, chat. As you can see, I'm designing for the future. Okay, let's implement this class diagram. A new package, DTO. Okay, we could use Java classes to implement the DTOs. But in this case, since all we need are some simple and immutable data carriers, I prefer to use Java records to implement the DTOs. But feel free to use Java classes. So the first one is chat request string model and a list of messages. The chat request record encapsulates the input to an AI model. Next, let's create this message record. It has a role and a content. So think of this role as a conversational role. It can be either system or user or assistant. And this content can be instructions, questions, examples, statements, or a combination of this. All right, let's move on to chat response. For simplicity, this chat response only has a list of choices. And that's not the choice we want. Here we're going to define this choice and then fix line number 3. Int index and message. Okay, then come back here. All right. So the choice record encapsulates a message that represents the output text generated by the AI model. Recall that by default, the AI model will only return one choice. So this list is really a one-element list. You may wonder why a response may have multiple choices. Each choice represents a possible output generated by the AI model from a single prompt. Multiple choices are offered primarily to provide diversity and a range of options for the user. This feature is particularly useful in scenarios where there isn't a single correct answer or where different perspectives or styles of responses might be valuable. But by default, there is only one choice, and the generated text can be extracted with this syntax. Okay, now let me close all those records. And let's go to the artifact controller. Now we're ready to implement the sequence diagram. Let's define a method stub in the artifact controller class. Public result. Summarize artifacts. Return null. Based on the API document, this should be a get mapping. Recall the endpoint should be API v1 artifacts summary. Since we have already defined the base request mapping URL at the class level, so here just /summary. Following the flow in the sequence diagram, let's go to the ArtifactService class. Scroll all the way down. And define the summarize method. Public string summarize, and it takes in a list of artifact DTOs. Okay, so here we just define the method stub. Next, based on the sequence diagram, the artifact service depends on this OpenAI ChatClient. But here I would like to adopt a good object-oriented programming practice and introduce an abstraction between the artifact service and the concrete OpenAI ChatClient implementation. So let's define a Java interface called ChatClient under the package client.ai.chat. So here, since the package DTO is already there, let me create this class in this way. It is client.ai.chat. The name of this interface is ChatClient, and it's an interface. So enter. Okay, there we go. So make sure this ChatClient interface is under package client.ai.chat. In this interface, let's define one method. Generate. The input is a chat request, and it returns a chat response. There we go. The generate method takes in a chat request instance and returns a chat response instance. So this interface will be used by the artifact service to communicate with the AI models. Why would I do this? Why not just define the OpenAI ChatClient? Take a look at this picture here. If you're familiar with OOP, you should know that an interface is, by nature, an abstraction. This abstraction can have multiple concrete implementations, enabling easy switch of components with minimum modifications to the code. This is called programming to an interface. As you can see in this picture, in our case, this chat client offers a uniform interface for interacting with different AI models. For example, it can have one implementation for OpenAI, the OpenAI ChatClient, but it can also be implemented for other AI models, like Google's Gemini. Can we add support for other AI models, like Anthropic's Cloud and Meta's Llama? Sure. Just create more concrete classes that implement the same interface. So by having our artifact service depend on this abstract chat client interface instead of a concrete OpenAI chat client implementation, we gain the flexibility to adapt to alternative AI technologies in the future. So if we no longer want OpenAI chat client, we can swap it out and swap in, say, Google Gemini chat client. The code in artifact service does not need to be modified. This is considered a good programming practice. It makes your code more flexible, extensible, and maintainable. All right, then let's create this OpenAI chat client. And have it implement chat client. Okay, OpenAI ChatClient will provide its own implementation of the generate method that defined in this abstract ChatClient interface. Since we're in Spring Boot, let's also make this one a Spring Bean by annotating it with add component. All right, then let's go to artifact service and inject the ChatClient into it. So here, let's define one more field, private final chat client. And we need to modify the constructor. Okay. So if we start the Spring Boot application, Spring Boot will automatically inject, in this case, the OpenAI chat client into the artifact service. All right, so let's go to OpenAI ChatClient. Next, let's work backwards. First, implement the generate method in OpenAI ChatClient class, then the summarize method in the ArtifactService class, and finally, the summarize artifacts method in the ArtifactController class. Recall that the responsibility of OpenAI ChatClient is to make HTTP requests to the OpenAI API and handle the responses. For that, it needs to use RestClient. So let's define it as a private field. Private final RestClient. Okay, it is from org.springframework.web.client. RestClient. Then we need to instantiate this RestClient using something called RestClient.builder. If you are familiar with design patterns, this is the builder pattern. Then how do we get this RestClient builder? We can have Spring Boot injected in through the constructor. But first, we need to make this RestClient builder bin available in the Spring context. And here is what we can do. We need to define this RestClient builder as a bin in a different class. So under client.ai.chat, so let's create a new class. Let's call this RestClient builder configuration. And in here, let's define a method that returns the RestClient builder as a bin. So it returns RestClient.builder. As you can see here, builder is a nested class within RestClient. Just call this RestClient builder. It just return RestClient.builder method dot request factory new JDK client HTTP request factory. There we go. So in this method, we created an instance of RestClient builder and then specified which HTTP library that we want to use. In this case, it is the JDK client. And don't forget to annotate this method as @bin. Okay, don't forget to annotate this class as @configuration. This is very important. Now this RestClient builder is available in the Spring context, and we can inject it into the OpenAI ChatClient through constructor. So here, let me define the constructor. RestClient.builder. RestClient builder. Okay. Now we get this RestClient builder we just defined. Then how do I instantiate the RestClient? It's very simple. This dot RestClient, then RestClient builder dot base URL. So this is the endpoint of the OpenAI API. So let me just put endpoint here. I know it doesn't exist, but it's fine. Then dot default header. Now recall that we need to set an authorization header. So here it should be authorization, and also the value of the header should start with barrel space, and also the API key. It doesn't exist now, but it's okay. And don't forget to close it with build. As you can see, we need endpoint and API key. That means we need to inject these two properties in as well. So let's define two configuration properties. Let's go to resources. And so here we're in development. So let's define the two properties in application-dev.yaml. Okay, so make sure there's no space here. Let's define the first property, AI, OpenAI endpoint. And here I'm going to retrieve the endpoint from an environment variable. So this is the syntax. And let's call this environment variable AI underscore OpenAI endpoint, all caps. I also want to provide a default value for this environment variable, colon, and paste. Let me put a comment here. Environment variable with a default value. Okay. Next, let's define the second property. It is named AI OpenAI API -key. And we're also going to retrieve it from an environment variable. Let's call it AI underscore OpenAI underscore API underscore key, all caps. And also I'm going to provide a default value, your API key. Let me copy this, put it here as well. There are many different ways you can set the values for environment variables. I'm going to show you how to do it in IntelliJ. So let's go here. Let me first copy this name. Okay, so there's no need to set the value for the first environment variable because the default one is correct. Here, I only want to set the value for the second environment variable. So let's go here and click Edit Configurations. And this is the current project. And let's click Modify Options. And we're looking for here, environment variables. Click here. All right. And paste. Now here is the format. The name of the environment variable equals the value. Okay, so equals. Then I'm going to copy and paste the API key here. Paste. Then click Apply. And OK. Now remember, treat your API key as a secret. All right, then let's go back to OpenAI ChatClient and inject the two properties into this class. And we can do that using the constructor injection. Add value. So here should be the first property name in application-dev.yaml, ai.openai.endpoint. And here we're going to define a formal parameter called endpoint to receive this injected value. That's the first one. Then the second one, follow the same syntax. ai.openai.api-key. And let's define a second formal parameter called API key to receive it. And comma. All right, now everybody happy? Okay, all right. Now everything's set up. Let's implement this generate method. Since this is a pretty simple and straightforward method, and it is your first time to use the RestClient, I will first quickly implement this method and then come up with some tests. So this is the syntax of using RestClient to make an HTTP POST request. This dot RestClient dot, as you can see here, you can make all kinds of HTTP requests, like get, post, delete, head, and so on. But here we're using post. Then dot, we're going to set a content type to, it's a media type, application JSON. Dot, body, and that is really the chat request. And RestClient will automatically convert it from Java object to JSON format. Dot, then it's time to retrieve the response. So retrieve. Now, once we get the response in JSON format, what we're going to do is extract the response body and convert it to chat response dot class. All right, there we go. So there's only one statement, but it's a pretty long one. I really like the Fluent API provided by RestClient. It reads like English. Next, let's come up with some tests for this method. So let's scroll up. Generate test for this method. And also let's check the setup. All right, so it's right here. This is the one. And let me close other classes. Okay, so the above is the class under test, and the below is the test class. We know that the OpenAI chat client depends on the REST client to interact with the OpenAI API. Recall that a key point of unit test is to test an object in isolation. So we don't want to call the real OpenAI API server in a unit test. We need to mock the behavior of the REST client. But then how can we do that? Let me introduce mock REST service server. So here, let's define a private field called mock REST service server. There we go. And I just call this mock server. We're going to use this mock server to mock the remote OpenAI API server. But here we need to use @autowired to inject it in. Here we also need to inject in the object under test. Private OpenAI chat client. Also need to auto-wire it in. So this mock REST service server is used to set up expectations and responses for API calls made by REST client. This approach allows us to test the interaction of the OpenAI chat client with the OpenAI API in a controlled environment. But as you can see, it's not happy. We also need to use this class level annotation called @RestClientTest, and also provide the name of the class under test to it. In this case, it's OpenAiChatClient.class. Okay, next we're ready to test this generate method. So let's scroll down. Also scroll down here. And first, let's test the happy path. So let's change this name, called test generate success. Recall that when defining a test case, we need to follow 3 steps. Given, when, and then. The given step is where we prepare some fake data and define the behavior of the mock. Now in this case, we're going to prepare the fake data for the request and a response, and also define the behavior of the mock server. The when is where we call the method to be tested. In this case, we can simply just call OpenAiChatClient.generate. The then step, which is also known as the assert step, is where we compare the result of the call with the expected result. If the assertion is evaluated to be true, the test has been successful. Otherwise, it has failed. Let's start with given. So first, let's prepare the chat request. So here, chat request, new chat request. Okay. Now the chat request takes in the model. So in this case, will be GPT-4, and then a list of messages. So here, list of new message. And we're going to pass a row, which is system. And then this is the content. That's the first message. Then the second message will be the data. This is the user message. And here is the content. And for the unit test, we can just make up some content here, like a JSON array. Okay. But here is the content. Let me copy and paste. So this is the same as the one you saw in Postman. Okay. So this is the request that we're going to pass to the generate method in OpenAI ChatClient. Next, let's define the chat response and also define the behavior of the mock server. So here is the chat response, new chat response. It takes in a list of new choice. And for choice, we need to pass two things to it. An index, in this case is 0, and also a new message, Okay, so let me break it here. In the new message, we need to pass, first, it's a row. Since this is a response from the OpenAI API, the row should be assistant. And then this is the message. The summary includes 6 artifacts owned by 3 different wizards. Okay. Let's make it large. We'll create instances for chat request and chat response. You should refer to the class diagram I created. All right, next, let's define the behavior of the mock server. So this dot mock server dot expect request to, and let's import this static method. Here I should write the URL of OpenAI API, but I do not want to hard code it here. So let's come up here and define a private field. It's called private string URL. And in the setup, let's initialize it. Paste. This dot URL. And then dot and expect the HTTP method to be HTTP method.post, and expect the header. The name of a header is authorization, and its value, I cannot really hard code the value here because that will leak the API key, but at least I can verify it, for example, starts with. Okay, let me import the static method from matchers, arrow, space, and keep going, and expect the content of this request .json. And here we need to use Jackson to convert the chat request to a JSON string. So that means we need to come up here and define in object mapper. Add auto-wired, inject it in, come down here. This dot object mapper dot write value as string chat request. So this line will check the chat request that we just defined here is really sent to the mock server. Now we're almost done, and respond. So if everything here is fine, we're sending request to this URL using a post request with a header called authorization, and the value starts with barrel space. And also the content of the request is chat request. Then the mock server will respond with success. Let's import it in. Okay. This dot object mapper dot write value as string chat response. So that's the chat response we defined here, right here. And here we should also have the media type to be application JSON. All right. Why are you not happy? Oh, we need to add exception to method signature. All right. So it's a pretty long given section, right? All right, now we're ready to call this method. So let's go down here. This dot OpenAiChatClient dot generate, and we're going to pass this chat request to it. And this is the generated chat response. All right. Then we're going to verify two things. First one is this dot mock server dot verify. Verify that all expected requests set up via expect and expect were indeed performed. And then assert that. Now make sure you pick this one, assertions.assert that from org.assertj.core.api. So don't import the wrong one. We're going to retrieve the summary from this generated chat response and compare it with this one here. Then how do I retrieve the summary returned from the mock server? Recall the class diagram. So here is the generated chat response. So first we need to get all the choices in it. Since there's only one choice, we just get the first one, the first choice. Now within this choice, we have access to its message. And within this message, we have access to its content. Okay. So this is how we retrieve the returned summary. I'm going to compare it with this summary here, the prepared one, semicolon. So let's go ahead and start the test case. Great, it passed. Okay, now let me close this to make this larger. Next, let's define more tests. Now this time, let's focus on the errors and problems. Now recall that the OpenAI API server might return a 401 unauthorized response. Let's test that. So add test void test. generate unauthorized request. Given, when, and then. All right. In given, I need to prepare the chat request again. Why not we extract the logic of creating this new chat request and put it in the setup method so it can be shared by all test cases. So let me copy this and paste. And let's make this a private field. Call this dot chat request. Let's change it to this dot chat request. And let's delete this part. All right. Now in this case, I only need to define the behavior of the mock server. So this dot mock server dot expect. So it's very similar to the previous one. We're still expecting request to this dot URL. We're still expecting a post request. Copy and paste. We should respond with unauthorized request. So that means the mock server will just return a 4.1. Okay. Now in when, we should define a catch throwable. And here we're going to use a lambda. This dot OpenAiChatClient dot generate and pass this dot chat request. Here is the response. And here, semicolon, and we're going to assign it to a variable. Let's call it throwable. That's good. In the then part, first let's verify all expected requests were indeed performed. And then assert that this throwable, let's change the name to thrown dot is instance of HTTP client arrow exception class. Okay. Be more specific, dot unauthorized class. Unauthorized is a nested class within HTTP client arrow exception. So this exception includes all the 400 level arrows, like 4.1, 4.3, 4.4, and so on and so forth. Unauthorized is just one of it. So basically, this test case, we're simulating the 4.1 unauthorized scenario. Next, let's consider more arrows. We should also create test cases for 429, 500, and 503. Feel free to pause the video and create those 3 test cases. Okay, as you can see, I created them offline. Test generate quota exceeded. Test generate server error, that's a 500. And the last one is server overloaded, which is a 503 error. Then let's run all the tests. Good, they all passed. Next, let's move on to ArtifactService. Let's implement the summary method in ArtifactService class. I split my screen vertically. The above is the class under test, ArtifactService. The below is the test class, ArtifactService test. As you can see, ArtifactService depends on ChatClient. To test ArtifactService in isolation, we need to mock the behavior of ChatClient. But first, let's inject ChatClient into this ArtifactService test class, just like what we did before for artifact repository and ID worker. That's called @mock ChatClient. Then let's scroll all the way down and define a test method for summarize. And also we're going to scroll down here as well. And let's call this @test void test summarize success. Given when and then. So here I'm going to adopt the TDD approach, test-driven development. That is, I will first implement the test case, and then based on the test case, implement the summarize method in ArtifactService. So here in given, we need to first prepare the input to this summarize method, artifact DTOs, and then mock the behavior of the ChatClient. Let's get started. Recall the structure of artifact DTO. An artifact DTO contains a wizard DTO. So let's create a wizard DTO first. New wizard DTO. And let's use Dumbledore as an example. Wizard ID is 1. Name is Albus Dumbledore. It has 2 artifacts. Next, let's create 2 artifact DTOs and put them in a list. List of new artifact DTO, and the second one. To save time, I've already copied the content. So this is for the first artifact DTO. So this is the ID of the first artifact, the name, description, image URL, and don't forget to pass the wizard DTO. And here is the content for the second artifact DTO. Same structure, just different data. So this is elder wand, description, URL of the image, and also the wizard DTO. Okay, that's the input to the summary method. Next, let's define the behavior of ChatClient. Given this dot ChatClient dot generate, an artifact service needs to pass an instance of chat request to this method, chat request, and then this will return an instance of chat response. And apparently here we have to prepare both. So first, let's create an instance of chat request. New chat request. And we're going to pass the AI model we want to use, GPT-4, and then messages. Now, since we don't have messages, we need to create a list of messages. List of the first message is a system message. And here I'm going to pass the prompt, copy and paste. Then the second message is a user message. We should provide a JSON array. So that means we're going to convert the artifact DTOs into a JSON array. And we can do that using Jackson's object mapper. Write value as string. We're going to pass this artifact DTOs. And you're not happy, so we're going to throw this exception. And then assign the JSON array to JSON array variable. Okay, make sure they match. All right, so that's the chat request. Next, let's prepare this chat response. And recall that response has a list of choices. And here, let's only define one choice. We should give an index 0 and a new message. Let me break it here so it's more readable. So for the message, since this is a response, this should be an assistant message. And here is the summary returned by the OpenAI API. A summary of 2 artifacts owned by Albus Dumbledore. Okay, so that's the response. We're done with the given section. Next, let's work on the when section. This dot ArtifactService dot summarize. Then we're going to pass to it artifact DTOs and assign the return summary in a variable called summary. Okay. Now in the then part, we're going to assert 2 things. The first one is assert that the return summary is exactly the same as this one. And the second one is we're going to verify that this .ChatClient, the generator method of ChatClient is invoked exactly once. And ArtifactService really called generate and passed the chat request to it. Okay, let's launch the test case. And can you tell me, do you think this test case will pass? Of course not. Because here we're expecting a summary of 2 artifacts owned by Albus Dumbledore, but actually we got null. This is not surprising because here the summary simply just returned null. Okay, now next, let me close this. Based on TDD, we need to write just enough code in summarize method to make the test case pass. Well, actually, when I write this test case, I've already defined the logic. For example, in summarize, we need to convert this input artifact DTOs into JSON array and prepare a chat request. What is missing is how to properly retrieve the summary from chat response. Okay, so go down here, let's copy some code. Copy. Paste it here. All right. And here we should call this dot ChatClient dot generate and pass this prepared chat request to it. And this one returns this chat response. Okay, so here instead of returning null, we should return chat response dot. Now recall how we retrieve the generated summary. Dot choices dot get 0, get the first choice in this choices list, dot message dot content. All right. So let me make some comment here. Prepare the messages for summarizing. And here is tell ChatClient to generate a text summary based on the given chat request. Okay. All right, now this time let's launch the test again and see if it can pass. Great, it passed. Okay. So this is TDD, or test-driven development. Next, let's move on to Artifact Controller. Okay, similarly, let's first define a test case in Artifact Controller test class. At test void test summarize artifacts success given when and then. Since Artifact Controller depends on ArtifactService, we need to mock the behavior of ArtifactService. So here, given this dot ArtifactService dot summarize. Now here, to make it easier, I'll just use Makito dot AnyList dot will return, for example, the summary includes 6 artifacts owned by 3 different wizards. So this syntax means that whatever list you pass to summarize, it will return this text. All right, for when and then, let's copy and paste the previous one and do some modification. So first of all, this is a GET request. And this base URL is good. And this one should be summary. The flag should be true. And the code is success. And the message should be summarize success, and the data should be value equal to this one. All right. How do I know those? You need to refer to the API documentation when you define a test case for a controller class. All right. Then let's launch the test case. And it will fail. So let's go ahead and implement the summarize artifacts. So in the summarize artifacts, we need to first find all artifacts from the database and then convert them into artifact DTOs. So here we can reuse some code from the find all artifacts method. So right here, so copy and paste here. Now, once we have this artifact DTOs, we can call this .ArtifactService.summarize and pass artifact DTOs to it. And let's call this artifact summary and return new result true status code dot success summarize success and this artifact summary. Okay, now let's launch the test again. Great, it passed. Last but not least, we also need to think about exception handling, because it's possible that OpenAI will return a response with either a 400 or 500 level status code. And we need to define an exception handler in exception handler advice. So let me close this and go to System, Exception handler advice. Okay, let's scroll all the way down. And first, let me fix this problem here. Okay, then let me copy this and paste it here. We need to handle RestClient exceptions, because RestClient will throw those 400 level or 500 level exceptions. So let me show you here. This statement here might throw a 400 or 500 HTTP exception. That's why we call it handle RestClient exception. Okay. We need to change the exceptions handled by this handler. This handler will handle HTTP client error exception class. That's the 400 level error. And also HTTP server error exception class. That's the 500 level HTTP error. And the status here, we're going to take it out. I'm going to show you a new way to define the status code. Okay, so let me delete this part as well. Okay, and here let's change it to HTTP status code exception. So this is a common parent class of these two subclasses. So here we're going to return a new response entity and pass a new result false get status code dot value. And here a message is a REST client error occurs. See data for details. All right, and then we're going to have a get message dot get status code. And of course, here we should change the return type to response entity result. All right. Okay, so this is easier to read. All right, we're done. Now let's start our application and do some integration testing in Postman. Okay, our application is up. Let's go to Postman. Okay, so let's go ahead and create a new HTTP request. Now this is a GET, and the URL will be localhost API v1 artifacts/summary. Okay, then let's click send. Wait a sec. Great, we did it. Flag is true, code is 200, message is summarize success, and here is the summary. Very good. You can add a new artifact or delete an existing artifact and test again, or change the ownership of an existing artifact and see the result. Next, let me test the 401 unauthorized error. I will go to IntelliJ and change my OpenAI API key to an incorrect key. Okay, I just modified my API key. Now it is incorrect. I launched my Spring Boot application again. Now let's hit send and see the error message. As you can see, the response is okay. It is false for 1. A RestClient error occurs, see data for details. But if you look at the data, it's not very readable, right? There are a lot of extra symbols like EOL, end of line, and also the error, type, param, code, and so on and so forth. But all we need is this message. Incorrect API key provided. You can find your API key at this URL and so on. So let's go back to the exception handler advice and better format the error message we got from OpenAI API. As you can see, we cannot simply just put the entire message in the result. We need to properly format it before we put it there. So here, let me copy and paste the code. Add exception to method signature. All right. So let's copy this formatted exception message and put it here. I have to admit that line 98 to line 113 are generated by ChatGPT. Actually, I was asking ChatGPT how to retrieve just the message part of this given JSON. And guess what? ChatGPT gave me this piece of code, and it works. Okay, then let's go back to Postman and test again. I have restarted my application, so let's click send. We'll get a better error message, just this part. Okay, now we have a very simple and clean, detailed error message in data. Let's go back to IntelliJ. Before I commit and push the changes to GitHub, I also changed my application-prod.yaml file. In a production environment, it is a good idea to save the API key in a safer place rather than an environment variable. In this case, I saved my API key in Azure Key Vault. I included a link in the top right corner of this video that guides you on using Azure Key Vault to save secrets. I also added many comments to the classes and methods we created in this video, so you can review them in the future. Check the GitHub link in the description of this video. Okay, let's run all the test cases. Okay, now let me commit and push the changes to GitHub. Git add, git commit, integrate OpenAI API with RestClient for artifact data summarization. Git push. Okay, then let's go to GitHub. Let's compare and create a pull request. Create pull request. Okay, this will trigger a Java CI workflow.
$2,000 later.
Okay, then let's go to pull requests. And it's time to merge the pull request. Confirm merge. And this will trigger the deployment workflow.
2,000 years later.
All right, the deployment is done. Let's go back to IntelliJ and synchronize the local main branch. Switch to main. Git pull. All right. Our local main branch is synchronized with the remote main branch. We're done. Let's go to the slides and do a quick summary. In this video, we used Spring Framework's RestClient to interact with the OpenAI API for summarizing the artifact data. As you already see, the RestClient offers a direct and simplified API interaction experience. We only scratched the surface of the OpenAI API. The OpenAI API offers capabilities such as text summarizing, the one I just showed you, inferring, transforming, expanding, and so on. It also supports images and audio. This AI magic can elevate our software's functionality to a new level. In my opinion, the capability to harness these advanced AI capabilities via API calls in a software application will be a game changer. Although we only covered text summarization, I hope that this video will spark your imagination about new applications that you can build. Welcome to the age of AI. In the end, I want you to be aware of the Spring AI project, which aims to streamline the development of Spring applications that incorporate AI functionality. As of the date of this recording, it is still in the snapshot stage. But once it is in general availability, or GA stage, I will try to refactor our application using Spring AI. Okay, I hope you learned something in this video. Again, welcome to the age of AI. See you in the next video.